When a bunch of numbers are churned out following a certain rule, we usually consider that as a sequence. Should we then decide to add these numbers up, we then consider it a series. We're going to look at two very accessible types of series, namely the arithmetic series and the geometric series, which will form stepping stones in our study of more complicated series in the future. Let's start off with the arithmetic series. Consider the first 100 counting numbers, 1, 2, 3, all the way down to 100. What is the sum of these 100 numbers? Let's help ourselves by writing S here, which stands for sum. Let's further help ourselves by writing a little 100 here to represent 100 things. For us to actually add this up, because you know that 1 plus 2 is the same thing as 2 plus 1, and addition is what we call commutative. A plus B is the same thing as B plus A. Let's write this exact same thing but backwards. Now that we've written it backwards, let's actually just add them vertically. So we get S100 plus S100 is 2 S100. 1 plus 100, that's 101. 2 plus 99, 101. 3 plus 98, 101, and so on. All the way to 100 plus 1, that's 101 again. However, how many 101s do I have? There's actually 100 101s. Why 100? Because there's 100 of these vertical columns. To finally get the answer of S100, let's just divide both sides by 2. And all of this will equal to 5050. What can we glean from the simplest example of what we call the arithmetic series? Firstly, we can see that every successive number is bigger than the previous number by the same amount. In this case, 2 minus 1 is 1, 3 minus 2 is 1, and if you remember there's a 99 over here, 100 minus 99 is also 1. We call this difference amongst the successive numbers the common difference, because it's the same. We normally abbreviate it as D for common difference. In this case, D for common difference is 1. Also, for this particular series, the first ever term in this entire chain of numbers is 1. So it's a happy accident that for this particular one, both common difference and first term happen to be 1. Let's talk about a more general arithmetic series. What can we glean from the simplest example of the arithmetic series? Let's generalize the arithmetic series to become an arithmetic series of first term A, common difference D. In this series over here, we have a series of n terms, where the alphabet n just denotes a very large number. We have n terms, the first term being A, the very first term. The second term, because an arithmetic series needs the common difference added onto it over and over again, we get A plus D, and the third term, A plus 2D, and the fourth term, A plus 3D, and so on, all the way to the last term of the last nth term, which is n minus 1 common differences added onto it. How would we extract a more general formula for the sum of an arithmetic series? Let's do the exact same thing previously of writing the same series below, but in reverse. Let's add them vertically now. Now, how many of these brackets of 2a plus n minus 1d are there? They're going to be n vertical columns. Oops. Once again, we don't want 2Sn, we just want Sn. So let's divide these two across. This over here is the sum of an arithmetic series with first term A, common difference D. In an arithmetic progression, the sum of the first 15 terms is 615 and the 13th term is 6 times the second term. Find the first 3 terms. Once again, in an arithmetic progression, the sum of the first 15 terms is 615. So the sum of the first 15 terms is 615. And the 13th term is 6 times the second term. The 13th term is 6 times the second term. Let's denote T13 to be term 13 and T2 to be term 2. So find the first 3 terms. Well, using this guy first, we know that 615 has got to be equal to 15 on 2, 2a plus 14d. Let's denote this as equation 1 and equation 2. But we also know that from equation 2, we know that the 13th term, a plus 12d, must be equal to 6 times the second term. And the second term has one common difference added onto it. Simplifying all of this, we see that equation 1 is given by 2a plus 14d is equal to 82. And we see that equation 2 is given by minus 5a plus 6d equal to 0. Now, if you remember anything from middle school maths, we know that if we got two equations with two unknowns, in this case a and d are the unknowns, we need to solve them through simultaneous equations. Because it's always a constant common difference being added on, I would suggest you should use elimination. And if we were to put this into our augmented matrix, 2, 14, 82, and minus 5, 6, 0. I'm just putting the coefficients down. And if we were to solve this, we get in this case, the first term is 6 and the common difference is 5. With that said, what are the first 3 terms of this series? The first term is going to be 6. The second term is going to be 11. And the third term is going to be 16.